Hi guys, again, this is Mr. Ward. It is day 4 of Unit 2, quadratic and absolute value inequalities. We're going to do a little warm-up here. I want you to do it on your own. It says find the x and the y intercepts of this following quadratic, this parabola. Sketch it up real quick, find those values. If anything is ugly decimal, round it for me. Otherwise, label all key points. Okay. Sad parabola, looks something like that. I use my intersect key with y2 equals 0 to find that to be -1. Find that to be 1 2/3, 1.6 repeating, and the y-intercept you can just get from the constant is 5. That should be pretty standard stuff for you. You did a lot of that in A2. I'm sure you're really good at it. All right, something new. Creating and using a plus-minus line. I didn't want to bog down with the mechanics, with the algebra. I want to focus on the mechanics. I don't want to bog down with the algebra. So I'm going to take a real simple inequality. Now, granted, you could solve that easy. X plus 4 is greater than 0. Solve and treat it like an equation. So if x plus 4 equals 0, then the solution is x equals -4. That is the root. That's the number. We're going to cut the number line from negative infinity to positive infinity into 2 pieces. All right. So here's what's true. Any number to the left of -4, whatever sign the value is, every number has that sign. Whatever, any number to the right of -4, whatever sign that number has when plugged into the expression, every number has. So let's plug -10 in. -10 plus 4 is a -6 negative. Every single number, I guarantee you, less than -4 to the left of -4 will generate a negative y value. Let's go to the positive one. 0 plus 4 is positive 4. So that's what that plus-minus line looks like. Okay. So now, after we choose a number on each side, I chose -10 and 0. All the numbers on that side have the same sign. So every single number to the left of -4, all the way to -infinity is negative. Right of -4 is positive. Now, if I had an inequality that was greater than 0, I'd be taking the positive regions, hence the right. If it was less than 0, negative left. So let's go back to our original inequality. Greater than, which means I want the positives. So that would be the solution of x is greater than -4. Not inclusive because there was no equal to. So that's the mechanics behind a plus-minus line. We're going to use it for all 3 types of inequalities. Absolute values, quadratics, and rationals. We're going to start out with a nice easy one, quadratic, because you're very familiar. Here's our steps. 2. Solve a quadratic inequality. We're first going to solve the inequality to 0. Okay? We did it already. It's already on one side, 0's on the other side. I didn't say equal to 0 because it's an inequality. We're going to factor and find the roots. Old school. So step 2. Factors of 21 that give you 10. X plus 7, x plus 3. I'm going to disregard the inequality for now. I'm just going to tee it up and find the roots as if it equals 0. -7 and -3. Step 3, create a plus-minus line with the solutions as partitions. -infinity to positive infinity. Left of -7, in between -7 and -3, and right of -3. Step 3, plug a value into each interval in the new inequality. So I'm going to pick the numbers. -10, -4, and 0. And I'm going to plug them into this inequality right here. Now, I like to use the factored version, and I'll tell you why. -10 plus 7 is a -3. -10 plus 3 is a -7. And since we're multiplying these two, a negative times a negative, that would give me a positive value. If I plugged it back into the original, I would get 10 squared is 100, 10 squared is 100. 100 plus 100 is 200. Plus 21 is 221. Okay? Now let's go to the middle. Again, I'm going to use the factor. Negative 4 plus 7 is a positive 3. Negative 4 plus 3 is a negative 1. A positive times a negative is a negative. And again, if I went back into the original, negative 4 squared is 16. 4 times 10 is negative 40. 16 minus 40 is negative 24. Plus 21 is a negative 3. And then the last one, 0 plus 7 is 7 times 0 plus 3 is 3. A positive times positive is a positive. As you get better at it, it's going to come to you a little bit quicker. Then, based on the interval we pick is based on the inequality. So, if I want it to be less than 0, that means I'm looking for the negative regions on my line. Is that negative here? Nope. Negative in the middle? Yup. Negative to the right? Nope. So this interval right here is my solution. And when it's in between, I always do this. I always do this. So what does that tell me? I can take any number in that interval, plug it into the original inequality, and it will work. Any number beyond will not work. You can test it. We already did negative 10. That was a gigantic big number. It's way bigger than 0. Didn't work. When we plugged in negative 4, we got negative 3. That is less than 0. And we plugged in 0. 0 squared, 0 times 10. 0 plus 21 is 21. Is positive. Every one of those numbers in that interval will work. Other numbers don't. So that's a plus-minus line approach. We're going to do the same thing repeatedly. So we got step 1 this time. Y squared minus 3y plus 2 is greater than or equal to 0. Now some people do this. Right now, they say greater than or equal to 0. I'm going to be looking for positives at the end. Because I'm never going to use that 0 until the very, very, very end. Is it factorable? It sure is. Y and y. Only factors of 2 are 2 and 1. Both are negative. Tee it up if you want to. Shortcut if you want to. Y equals 2, y equals 1. Now I'm going to create my plus-minus line. One here, 2 here, 3 regions. What's the number to the left of 1? 0. The number in between 1 and 2, 1.5, and the number greater than 2, 3. And again, I'm going to throw them into the factored version. Now, I'll show you what I'm saying. If you're not following, 0 goes into this factor, 0 minus 2. 0 goes into this factor, 0 minus 1. A negative 2 times a negative 1 equals a positive. Middle region, 1.5 minus 2 is a negative. 1.5 minus 1 is a positive. A negative times a positive is a negative. And 3 minus 2 is a positive. 3 minus 1 is a positive. A positive times a positive is a positive. So as you get better at it, again, you may not need this part up here. I just wanted to show you where I was getting those values. You may not even need this other sign. You might just jump to the plus, minus, and plus. And what did we say we wanted back at the beginning of the problem? We wanted the pluses. So what does that mean? This inequality would be to the left of 1 or less than 1. And since it's less than or equal to, 1 would work. Or greater than 2. Greater than or equal to 2. So almost every number from negative infinity to positive infinity would work in this inequality except for the numbers like 1.5. And if I plug 1.5 into the original, 1.5 is 3 halves. 3 halves squared, greater than or equal to 3 times 3 halves minus 2. Let's see if this is true, because it should not be. 3 halves squared is 9/4. otherwise known as 2 1/4. 3 times 3 halves is 9 halves, otherwise known as 4 1/2. 4 1/2 minus 2 is 2 1/2. Is 2.25 greater than or equal to 2.5? It is not. But almost every other single number is. Again, we use that plus minus line idea. Really important concept to grasp. Quadratics. One more. I don't think we need to do them both. And then we'll take a break because our 15 minutes will be up, and we'll do our second video just on absolute values. All right, so let's pull it all over to 0. Pardon me. Can't pull 2 out. 2x squared minus 11x plus 5 greater than or equal to 0. 2x, x. No choices, 5 and 10. 5 and 1. To make 11, the 5's got to go here, the 1's got to go here. Both are negative. Foil it in my head. Negative 10, negative 1 gives me negative 11. Tee it up. X equals 1/2 and x equals 5. Go back here again if I want to. I'm going to look for the pluses on my plus minus line. Let's make it. I have a region to the left of 1/2, in between 1/2 and 5, and to the right of 5. Pick easy numbers. 0, 1, and 6. If I plug them into the factored version, 0 minus 1 is negative 1, 0 minus 5 is negative 5, and negative times a negative is a positive. Plug 1 in. 2 minus 1 is positive, 1 minus 5 is negative, positive times a negative is a negative. Plug 6 in, a positive, 6 minus 5 is a positive, and positive. And we want the positive regions, so what are our answers? X can be less than or equal to 1/2, the first partition, or it can be greater than or equal to 5, our second partition. Quadratic inequalities, set them to 0, factor them to find partitions, put on the number line, figure out which ones are plus and minuses, go back to the original inequality, determine which ones you want, and that's your solution region right there. I know sometimes in the years past you've done things like shading and arrows. We're not doing that. I really want you to do the method that we're using right here. I don't think we need to do example 4. Seems to make a lot of sense, and I think we got it. All right. I'm going to call it here. We're going to put video 2 into absolute value inequalities, but again, with that plus minus line idea. Talk to you in a minute.